In the last video, I did an outro where I did multiplication of polynomials, and I did an outro which is a description of the paths that forms that is a resultant of division of polynomials. I talked about the algebra of polynomials where we divide polynomials, add and multiply polynomials. So these are the steps that is required for you to divide polynomials. I just constructed this with my own language. I hope you understand that. The first step is to divide the first term of p of x, which is what you want to divide, by the first term of the divisor. Multiply. Second step is to multiply the answer of the last step by the divisor. And the third step is to subtract the answer of the last step from the current list. And you continue that until the power of the remainder is less than that of the divisor. I know sometimes for a new student this is like bad dash, I'm just talking rubbish. But by solving problems, like an example here, you get to understand this step very well and apply it. So I have a question here, and the question there is for you to divide that. So we can bring in our division sign, which we used to use in our earlier grade. So we have 3x cubed plus 5x squared plus 2x plus 1. That's what we are dividing, and the divisor is x minus 1. So we look at ourselves. The steps divide the first term. This is the first term of our p of x. This is our p of x. Mistake note. Our current p of x. Remember, it's the current. So our current p of x. So divide this first term by the first term of this divisor. So this is the divisor here. So we divide this by this, and that will be 3x cubed divided by x, and that is 3x squared. Please, whenever I do something like this you don't understand, refer to the first and second video. I made an explanation of this. So that's going to give us 3x squared. So the next step is multiply the answer. This is the answer now of the last step by d of x. So we multiply this answer by this divisor. So we multiply this by this multiplication of polynomial and multiplication of polynomial. This time this is going to give us 3x cubed, that is this times this, and this time this is minus 3x squared. So the next step is what? Subtract the answer of the last term from p of x. So we subtract this answer now from this, and that will be what? This minus this is 0, obviously. Then 5x squared minus 3x squared is 8x squared. Please take note of that. That is addition of polynomials. 5x squared minus gives us plus. So 5x squared minus 3x squared is 8x squared. So this, we don't have anything here. So this minus 0 is just 2x, and this is just 1. That is that. So this is like we are done. This is like the first step. Then we start all over again. Now we divide the first term of p of x. So these are our new p of x. These are all gone now. These are our new p of x now. So we divide the first term again by the first step of this. This by this is going to give us 8x. The next step again, divide the answer. This answer, multiply the answer of this last step by d of x. So multiply this answer again by this, and that's going to give us 8x squared. This time this is minus 8x. So we subtract again. The next step, subtract this again. This is going to give us 0, and this is going to give us 2x minus 8x, and that is 10x plus 1. We are done again. We start again afresh. The first thing again, divide the first term, which is the first term, by the first term of this. The first term here divided by this, that is going to give us obviously 10. Next step is to do what? Multiply. So we multiply the answer with this. So 10 times this is going to give us 10x minus 10. 10x minus 10. So this times this 10x minus 10. And we subtract again. The next step is subtract. This minus this is 0. 1 minus 10 is 1 plus 10, which is 11. So you can see that this is, what is happening here? Continue till the power of r of x. So the r of x is the remainder. The power of this is actually 0.
and the power is less than the power of this. So once that happens, this will stop. It means that our answer to this question, our answer f of x, is actually what? 3x squared, which we call the quotient. We call this the quotient. 3x squared plus 8x plus 10. So this is our answer, and the remainder is actually 11. But what if you wanted to get this remainder and you're not interested in this? Yes, you can do that without having to do all this. It's called the remainders theorem. It is called the remainders theorem. What does the remainders theorem say? The remainders theorem says is to substitute. First step, you should take your quotient, equate it to 0. You will have x as what? 1. You do this. So that is what the remainders theorem tells you. Then substitute this one here. You are going to get this remainder automatically. I'm sure that is a shock to you. So we can get this remainder without having to do all this. How do we do that? Let's substitute this x as 1 into this polynomial. So that will give us p of 1, and that will be equals to 3 into 1 cube plus 5 into 1 square. That's replace it for x, plus 2 into 1 plus 1. And this is going to give us 3 plus 5 plus 2 plus 1. And we say that that is 8 plus 2 plus 1 is 11. So that's another way we can get the remainder without having to do all this. And that is actually called the remainders theorem. Remainders theorem. But I round up my video by talking about what we call factor theorem. If we had substituted this value into this equation and we had 0 here, or we did this division and we had 0, then this is a factor of this. Then this man is a factor of this. And that we call factor theorem. If at the end of the day we substitute this value into this and we have 0 at the end of the day, that's what we call factor theorem. So factor theorem is simply saying that if we have p of x and we have d of x, d of x is a factor of p of x if what? P of a is equal to 0 and d of x is the same thing as what? A function of a. So that is simply what we're talking about in factor theorem. That is basically what we can learn in division of polynomials, factor theorem, and remainders theorem. I'm expecting much question from you. This is how far I can go polynomial. In the next series, I'm going to be talking about radicals, and later on I will discuss vectors, and that is how we'll round up this series. Thank you and bye.